Hi guys, myself Kunal and we are learning machine learning and AI here. So abhi tak we have understood and studied some basic functionality of NumPy package and we have seen that NumPy is used for mathematical operations on array and matrices. It provides a very easy way or relatively easy way than normal Python to handle arrays and matrices. Pandas एक another important library है और पैकेज आई कैन से पैकेज है पाइथन का जो हम बहुत ज़्यादा यूज़ करेंगे while we'll do coding for machine learning and AI. तो प्लीज फोकस ऑन दीज 3-4 वीडियोस अपकमिंग 3-4 वीडियोस में हम पांडास के बारे में डिस्कस करेंगे. We will learn only basic functionalities of pandas. You can get this notebook, Jupyter notebook, um, in the links below. Use it, open it on your Jupyter notebook or any other Python IDE. Run its code step by step while watching this video और आप और better way में इस वीडियो को अंडरस्टैंड कर पाएंगे. So first we come to installation part. So अगर आपने Anaconda के थ्रू Python इंस्टॉल किया है तो pandas and numpy you will get in free और I would say कि आपको इंस्टॉल करने की जरूरत नहीं पड़ेगी. लेकिन अगर आपने Python को अलग से इंस्टॉल किया है then you need to install both numpy and pandas. Panda is a package used for managing data. Pandas को हम मशीन लर्निंग एप्लीकेशंस में उसी तरह यूज करते हैं जैसे हम एसक्यूएल को यूज करते हैं फॉर मैनिपुलेशन ऑफ डेटा इन आवर नॉर्मल एप्लीकेशंस. Pandas के साथ we gonna learn two new data types for storing data that are series and data frames. आप Panda data frame को you can think it like Excel spreadsheet to store some data and each column of that Excel spreadsheet will be your series. So हमें दोनों डेटा टाइप क्लियर हो गए हैं. सीरीज क्या है और डेटा फ्रेम क्या है. Of course we'll discuss more about them in upcoming videos. So एक्सेल शीट हमारी डेटा फ्रेम है और उसका हर एक कॉलम is our series. Excel is our data frame and each column of it is series. So we can say the data frame is made of several series. अच्छा अगर if you have used R library then series or Panda data frames are exactly same there as well. So start करते हैं pandas से. So जैसे हमने देखा था कि we need to import numpy as np. Similarly, this is standard practice to import pandas as pd. If you ever learn a proved Python code or have you ever came through a proved Python code, then pd will be used there for pandas only. So we'll start in this way. First check there are two data types of in pandas, data frame and series. So let's see how we can use these data types and then we'll do manipulation of these data types, storing some data in these data types, accessing data from these data types, and then different mathematical operations on these data types, then storing these data types on text files, and we'll learn how to code in using pandas in upcoming videos. So we have learned there are two type of lists we have learned so far. First is basic Python list and that second is numpy array. So let's say I have created a my list with four values 5.4, 6.1, 1.7 and 99.8, and I have converted this list to an NP array as well, so that we're gonna see that how to create a series or pandas data types using both basic Python or NumPy. Okay, so let's say I want to convert both of these two into pandas and I want to do operation on these two in pandas. So सबसे पहले मैं pd I'll use pd.series function to convert data to Panda series. So I provided data equal to my list in constructor or function argument. This is my Panda series. We'll print them. And second, I can provide data as numpy array also in series function. If we print both of these two, so see, now analyze this output. This output is in column shape format, like we see columns in Excel sheet. So zeroth column, as all the Python packages start from zero, because zero Python indexing start from zero. So at zero index, we get 5.4, 6.1 at one index, 1.7 at second index, and 99.8 as third index. But we get all the values in column format. So 5.4 is our first row, 6.1 is in our second row, 1.7 is in our third row, and data type is float 64. Okay, so now this is important. As till now we have learned कि series जो array list थी या numpy की जो array थी, उसमें हम किसी भी तरह के data types provide करा सकते हैं. So it can be combination of string, integer, float, everything. Okay, but in a column, in a Excel sheet column, we can provide only single type of value or single type of data type. Like all these value are float here. Okay, if I change it to, let's say I change it to a string. Let's see what happened. So control enter and then control enter. See, now data type has been changed to object. It stores the data, but the data type is now not defined. It's treating all the values as an object. So these are not float anymore. These are object for pandas. Okay. We can access individual entries the same way as with list and arrays. So we can provide an index location and we'll get the entry. Let's second index location, we get entry 1.7. As now we are, this is an important functionality of pandas, or we can say add-on functionality of pandas. We can add labels to the entries of a series. So my label, we have declared a series here, first, second, third, and fourth. Okay, list. We can provide this labels to my panda series, data equal to my list, which is our data, original data, my list, and index is equal to my labels. And if you print this, so it has assigned these labels to the series values. So first, second, third, and fourth, and data type is float. Again, control enter. Data type is object because we have changed it. So let's change it back to float. So 2.4, control enter, and control enter. 64. Okay, यहाँ पे हमने data variable names भी provide किए थे, which is not necessary actually. We can directly provide data and then labels. To print, it will print this. Okay, now there is no you understood right कि हम कुछ भी label में provide करा सकते हैं. I can provide it my name here, Kunal. So it says Kunal. So it's not like first, second, third, and fourth. It can be anything. Okay. So let's change it back to second to avoid confusion in future. Okay. Now we have two ways, as we have provided labels to the series. Now we have two ways to access the values of series. We can access it using the label, or we can access it using the indexing. So second is our first index. We can provide one here and the values are okay. Now in both we have not encountered data frame till now, but series pe we can do mathematical operation as well on two series. So we can create this series directly. pd.series, first is our data and second is our label array. So we have provided the variables here. Now we are providing the initializer list of variables. So my series 5, and if you do add my series 5 plus my series 4, so it will do the addition on these label basis. Okay, so we have here first, second, third, and fourth, and in this we have first, third, fourth, and fifth. So second is not present in this series, and fifth is not present in this series. So let's see what happened here. So this is my series. Let's print my series 4 also. Okay, so it has first, second, third, fourth. It has first, third, fourth, fifth. So first plus first, 5.5 plus 5.4 is 10.9. Then second, 6.1 plus second is not here. So second plus addition of which is not exist something, it will giving not exist, nan. Second is this nan. So okay, this is coming as sorted list on label basis. If we provide sort equal to false, then it will not sort it. So let's say I provide it here, sort equal to false, paranet. I guess I did some mistake here. So this one is okay. Okay, okay, sorry. Sorry, I have providing it here. You can provide it. False. Let's see what happened. Okay, so print also not supported, sort equal to false. So okay. So we can see the sorting functionality here. Let's use pd.concatenate function. And if we are concatenating two series, my series 4 and my series 5, now x is equal to 1. As we know that Python, everything starts from index 0. So x is equal to means 0 means x-axis and 1 equal to y-axis. So y represent column, and we have provided sort equal to false here explicitly. Let's remove this sort equal to false and see what happens. What happens? Enter. See. So it concatenated two series on column basis, 0 column and 1 column. We got first entry, second entry is not present in the second list, and similarly fifth entry is not present in the first list, so it is replaced by nan. And these things are, if I do this, okay, if we do sort equal to true here, and run this, see now the output is, our output is sorted. So we can add a concatenate this. So this is a data frame. We have created a data frame which has multiple series in it. So this is also data frame. Let's create a new data frame here, and let's see. the way we created series, this is a way to create a data frame, and let's see what are there another ways to create a data frame. So I am creating a data frame with random normal variables and with a 5 cross 5 rows and 5 column data frame. This is my data frame with random variables. Let us assign some labels to both columns and rows. So index is our rows and columns are our column. So let's call it first row, second row, third row, fourth row, and fifth row. And this one first column, second column, third column, fourth column, and fifth column. So I've used pd.dataframe function here. I'm providing this random variable, the initializer value here, index equal to this index list, and columns equal to column list. Now our entries are replaced by labels, but as we can access different values of series using the original indexing, the basic indexing 0, 1, 2, 3. Similarly, we can access the values of data frame using basic indexing as well. So let's say I want to get second series. So all these are series. First column is a series, second column is another series, third column is another series, fourth column is another series. We can access each series individually. We can do manipulation on each of the series. So let's say I want to access second series. So df3.second column is my second series, and similarly I can get two series as well, first column and third column. So it is creating my another data frame with two columns. We can access rows of a data frame as well. So in both NumPy and basic Python, this square bracket supports row values or row list, but in Pandas, this is to note here, Pandas, by default, the square bracket denotes a series because series is basic data type for Pandas. Okay, so if we want to access a row, we can use LOC function. It's giving me values of fourth row. This is our fourth row, first column, second column, third column. So each column values corresponding to this row. These are the floor 64. Okay. Okay. Now let's say we get the multiple rows here. So we are getting fourth row, first row, and their second column and third column. Row and column values we have specified. So instead of getting all the columns for each row, we are getting specific column for each row. In NumPy, we have used logical indexing to get the values. So similar logical indexing we can use in data frames as well. Let's say I want to get all the values that are greater than 0 in my df3 data frame. So I can use this. df3 greater than 0 will give me this logical index matrix, which give true false values. Where this condition is satisfied, it will give true. Where this condition is not satisfied, it will give false. And when I'll do printing of data frame using this logical index matrix, I'll get the values which are true. So, and which are false, I'll get NaN correspondingly. See, all these four values are false. This one, this one, this one, this one, and I got NaN corresponding to all of them. It says that value do not exist. Only it will show the positive value. In NumPy array, if you provide this kind of input, then it will break the matrix and it will output you a NumPy array. But in Pandas, it will maintain the data frame because it has data frame as its basic data type. In Excel sheet, value can be not exist for some row or some column. But for matrix, it is compulsory to have all the values to call it a matrix. Otherwise, it's an array. So like this, we have functionality to add sixth column as well. Of sixth column has been added here. Remember, square bracket will always denote the series in it, so we can add it here. So we are adding 5 rows and 1 column corresponding to this. Let's say I have had 2 column. Let's see what happened. So it, as we have specified a column here, it adding a single column here. Let's say I modified it to 4. Let's see what happened. It will again give an exception because data frame should have the random number variable should create all the rows that are required in this data frame. So let's say I mention it 6 here, then also it will give error. Okay. Okay, so as functionalities are similar to Excel, we can add a data. So there should be a way to remove the series as well. So we can draw first column. Okay, let's see what's happened. It says that first column is not found in this axis. Okay, because we have already deleted it. It has been deleted from the data frame already, and we are again deleting it. So let's say we use it second column. See guys, yeah, Python provide you the detailed debugging. It told you that key error, first column not found in axis 1 we are using. So now it has removed the second column. If we print df3, see, so first and second both columns are removed here. Okay, we have already dropped first column from it. So let's run this. Let's create df3 again. Okay, now let's come here. Okay. So we have provided x is equal to 1 here, means we want to remove from columns. Okay. If you not provide correct access here, it will give an error saying this column does not exist. Similarly, we can remove a row as well. So the second row is removed. If I somehow incorrectly give access 1 here, it will say that this does not exist, second row not found in columns. Okay. So this is why access is used. Okay. We can reset data frames index values. What it means is this is our index, first, third, fourth, fifth row. So if you know what happened here is we have removed our second row. We have dropped our second row. The reset indexes now make these values as our original indexes. So now first row is 0, but second row is removed. So first will be assigned to third row and second will be assigned to fourth row. Similarly, third will be assigned to fifth row. Okay, so we can assign a new name to the indexes as well. So let's say I'm adding a column, new name. We can add a column. This way we add a series here, or let's say column here. This is the row, and then we can use set index function to set new name as its original index. So it's removed its existing index, and we have assigned a new index to this data frame. So thank you guys. Let's stop in this lecture. In this lecture, we have learned that how to create a series, how to create a data frame. I'll try. See, I have use in place at many location. I'll tell you about it. I have not discussed about it here. I'll tell you about it in detail in my upcoming video, in my next video, where we learn about combining data frames. Combining data frame will be similar to SQL. Then we're gonna learn how to store entries in a sheet or a text file for data frame and how to get data frame back. So keep watching the video. Thank you.